Key exchange is any method in cryptography by which cryptographic keys are exchanged between two parties, allowing use of a cryptographic algorithm. If the sender and receiver wish to exchange encrypted messages, each must be equipped to encrypt messages to be sent and decrypt messages received. The nature of the equipping they require depends on the encryption technique they might use. If they use a code, both will require a copy of the same codebook. If they use a cipher, they will need appropriate keys. If the cipher is a symmetric key cipher, both will need a copy of the same key. If it's an asymmetric key cipher with the public-private key property, both will need the other's public key. The key exchange problem is how to exchange whatever keys or other information are needed so that no one else can obtain a copy. Historically, before the invention of public key cryptography, symmetric key cryptography utilized a secret key to encrypt and decrypt information. For two parties to communicate confidentially, they must first exchange the secret key so that each party can read encrypted messages as well as send them. This process is known as the key exchange. The overarching problem with symmetrical cryptography or a single key cryptography is that it can require a secret key to be communicated through a trusted channel. If the two parties cannot establish a secure initial key exchange, they cannot communicate securely without the risk of the key being compromised. Let's say, for example, Amy and Bill are wanting to communicate with each other. They want to make sure that their communication is confidential and that they are in fact communicating with each other. In other words, that the other person is authenticated. When Amy randomly selects her secret key, she has to somehow send it to Bill. But she doesn't yet have a secure channel to communicate with Bill, so she can't encrypt the key. If she sends it by email or some other unencrypted means, a third party, like Mal, might intercept the key in transit and use the key to eavesdrop on all subsequent communications between Amy and Bill. To compound the problem, what would Bill do once he received the key from Amy? He has no way of verifying that the key sent to him was in fact from Amy. If Mal is clever, he could impersonate Bill and send a fake key to Amy, then impersonate Amy and send a fake key to Bill. This would have the same effect as intercepting the key that Amy was originally sending to Bill legitimately, and Mal would be able to eavesdrop on all their communications. The solution to this would be to use a out-of-band key exchange. This simply means that Amy and Bill can use a different channel that they both trust. For example, if they are familiar with each other's appearance, they may arrange a face-to-face meeting at a local coffee shop. Or if they are familiar with each other's voices, they may call each other. These options, however, present their own set of challenges. For example, what if Amy and Bill live in two different cities? Arranging a face-to-face meeting in that instance would not be feasible. The alternative solution is to use an in-band key exchange. In an in-band key exchange, the key exchange is done digitally, and one way this can be done is through the Diffie-Hellman algorithm, which we will discuss next.